Good afternoon, everyone. Myself, Vishnu Kumar Singh, working as a senior lecturer in Department of Mechanical Engineering, IIMT College of Polytechnic, Greater Noida. Today, the topic that we will be discussing is transducers. Now, before understanding what a transducer is or dividing into different types of transducer, consider the following setup of a measuring system. In this block diagram of a simple measuring system, there are three basic elements: a sensor, signal conditioning unit, and data representation device. Now, let's see what exactly a sensor is. A sensor is a device that is used to detect changes in any physical quantity like temperature, speed, flow, level, pressure, etc. Any changes in the input quantity will be detected by a sensor and reflected as changes in output quantity. Both the input and output quantities of a sensor are physical in nature, that is, non electrical in nature. Now, next thing is the signal conditioning unit. The non electrical output of the sensor makes it inconvenient to further process it. Hence, the signal conditioning unit is used to convert the physical output of the sensor to an electrical quantity. Some of the best known signal conditioning units are analog to digital converters, amplifiers, filters, and rectifiers. Then comes the data representation device. A data representation device is used to present the measured output to the observer. This can be anything like a scale, an LCD display, a signal recorder. In the above example, let us consider a strain gauge as the sensor. Any changes in the strain will reflect as changes in its resistance. Now, in order to convert this change in resistance into equivalent voltage, you can use a simple Wheatstone bridge circuit which acts as a signal conditioning unit. Now, the combination of strain gauge and Wheatstone bridge circuit is known as a transducer. From the above example, we can see that a transducer is a device that converts a physical quantity into an electrical quantity. Now let's see what exactly the definition of a transducer is or how we can define it. Generally speaking, a transducer is a device that converts one form of energy into another by the principle of transduction. For example, a microphone is a sensor which converts sound waves into electrical signals, and a loudspeaker is an actuator which converts electrical signals into audio signals. Both microphone and loudspeaker are transducers in the sense that a microphone converts sound energy into electrical energy and a loudspeaker converts electrical energy into sound energy. Now let's see what are the components of a transducer. It has basically two main components, one which can respond to the physical change and other which converts the response of the first one into electrical signal. These two parts are called sensing element and transduction element. Now let us see what exactly is a sensing element. A sensing element, also known as a detecting element of a transducer. It is a part of transducer which responds to the physical phenomena or change in physical phenomena. A sensing element is the first in the process of conversion of one form of energy into other. It is also known as primary transducer. Next element is the transduction element. A transduction element is the part of the transducer which converts the output of the sensing element into electrical signal. Since it is the secondary component used in the process of conversion, it is also known as secondary transducer. Now let us see the working principle of a transducer. A transducer has combination of detecting and transduction element. It changes one form of energy into another. The sensing element responds to the physical change and generates its output. This output may be in the form of displacement, angular displacement, strain, etc. The output of the sensing element is then linked to the transduction element. This element is so designed to act upon the response of sensing element and generate a proportional output in the form of electrical signal. Now let us take an example to better understand the working of a transducer. Now LVTD, that is linear variable differential transformer, is a transducer which converts the linear displacement into output voltage. In LVTD, an arm is attached to the soft iron core. The arm responds to the linear displacement. Due to the movement of the arm, the displacement of the soft iron core takes place, which causes change in the generated EMF in the secondary winding of the transformer. Here, the transformer along with the core is the transduction element. Now, what are the applications of a transducer? Some of the major applications of a transducer are as follows. It is used in various home appliances such as air conditioner to sense room temperature and control it. In microphone, the sound wave is converted by a transducer into an electrical signal. Similarly, in speaker, electrical signal is converted into sound wave. Thermocouples are used in industries to monitor and control system temperature. In medical industry, accelerometograph is used to measure the muscle movement after nerve stimulation. Nuclear radiation is measured using transducer, which transforms the radiation energy into electrical signal in direct reading dosimeter. In communication systems, the electromagnetic waves get converted into electrical signal using transducer in antenna. In digital thermometer, the body temperature is converted into electrical signal. The photovoltaic cell is also an example of a transducer which converts sunlight into electrical signal. Changes around the circumference of a chest is measured with a pneumograph that has a photodiode which acts as a transducer. It is also used in robotics and automation to convert movement into electrical signal. It is used to sense the pressure of process fluid and convert it into electrical signal. So, as you can see, there are various applications of a transducer in day-to-day life. Next comes the classification or the various types of transducer. Now, the classification of transducer is based on the following five ways. Firstly, physical effect, then physical quantity, source of energy, transducer and inverse transducer, then comes the mechanical and electrical transducer. So basically there are five ways in which we can classify a transducer. So let's see the first classification, which is based on the physical effect. The first classification of transducer is based on the physical effect engaged to convert the physical quantity to electrical quantity. As an example, it is the change in resistance of a copper element in proportion to the change in temperature. The following physical effects are generally used. Now, firstly, variation in resistance, then variation it could be a variation in capacitance, variation in inductance, Hall effect or piezoelectric effect. Now let us see what is a Hall effect transducer. It is used for measuring the magnetic field by converting the field into an EMF. The straight determination of the magnetic field is not achievable. Therefore, the Hall effect transducer is used. It converts the magnetic field into an electric quantity, readily estimated by the analog and digital measures. The piezoelectric effect states that when mechanical stress or forces are applied to a quartz crystal, generates electrical signal on the quartz crystal surface. Now, the second way of classification of transducer could be based on the physical quantity. Like firstly is the temperature transducer, such as thermocouple. A thermocouple is a device that converts the thermal quantity into physical one. Then comes the displacement transducer, for example, LVTD, that transforms the linear motion into electrical signal. Then comes the pressure transducer, such as diaphragms, which is an instrument that measures the pressure of a fluid, denoting the force the fluid is applying on the contacted surface. Then comes the flow transducer, which is utilized to measure liquid and air flow velocity. Then comes oscillator transducer. It can be used to measure pressure, displacement, or force by converting it to a voltage. Next is the inductive transducer, in which a movement among a conductor besides the magnetic field causes a voltage inside the conductor. So these are all basically the classification of a transducer based on the physical quantity. Now, next classification is based on the presence or absence of an external power source. So in this case, we have two types of transducer. First is the active transducer. An active transducer is a self-generating type transducer that has the ability to generate electrical voltage or current as its output without using any external source of power. These transducers draw the energy needed for their operation from the measuring system itself. It is noteworthy in this case of active transducers that the output produced is very small. Thus, further amplification is required in its case. The various examples of active transducers are as follows. Firstly, tachogenerators. These are basically used to measure angular velocity. Then comes the thermocouples. Temperature measurement is accomplished using thermocouples. Then piezoelectric crystals. These converts charges generated by application of force into electric potential. Then what are the exactly passive transducers? The passive transducers take the power from the external energy source for transduction. In passive transducer, the output is obtained by changing the physical properties of the material. Could be the physical properties could be resistance, inductance, or capacitance. Therefore, these transducers are classified into resistive, capacitive, and inductive. The resistive type mainly includes a thermistor, resistance, strain gauge, and photoconductive cells. The inductive type includes LVDT, and capacitance includes photoemissive and the devices which are based on Hall effect. Now, apart from these, optoelectronic transducers are there, which use the principle of converting the energy from light to electrical. Some of the examples of optoelectronic transducers are photoconductive cell, photovoltaic cell, solar cell, photomultiplier tube, and photomultiplier. Next classification of transducers are transducer and inverse transducer. Now let us see firstly what exactly is a transducer. It is a device which converts non-electrical quantity into an electrical quantity. And what is an inverse transducer? The transducer which converts electrical quantity into a physical quantity. Such type of transducer is known as inverse transducer. The transducer has high electrical input and low non-electrical output. Next is the mechanical and electrical transducer. Mechanical transducers respond to change in physical quantity with a mechanical output. The output mechanical quantity could be anything like displacement, force, pressure, or strain. Electrical transducers are those that respond to changes in physical quantities with electrical output. Now comes the question is why is basically the physical changes are converted into electrical signal. So this question arises is that why what is the basically the need for converting the physical changes into electrical signal. So let us see that. Now there are number of transducers which transform a variety of physical quantities and phenomena into an electrical signal. The advantages of converting physical quantity into electrical quantities are as follows. Firstly, electrical amplification can easily be done. Secondly, the mass inertia effect is minimized. This is because when dealing with electrical signals, the inertia effect are due to electrons, which have negligible mass. In many situations, we do not come across mass or inertia problem at all. The effect of the next point is the effect of friction are minimized. The next is the processing and controlling of electrical signal require less power. Next is the electrical output can easily be used, transmitted and processed for the purpose of measurement. Modern digital computers make use of these transducers absolutely essential. Now let us see the commonly used transducers. First is the electrochemical transducers. Examples are a fuel cell which converts the energy from a reaction within a fuel cell to electrical energy. Next is the battery which converts chemical energy directly into electrical energy. Next type of transducer is electroacoustic transducer. Examples are loudspeaker, which converts an electrical signal into sound, then microphone, which converts sound waves into an electrical signal, then hydrophone, which converts sound waves in water into an electrical signal. Next type of transducers are electromagnetic transducer, like magnetic cartridge, which converts motion in a magnetic field into an electrical energy. Then comes the generator, which converts motion in a magnetic field into electrical energy. Then comes the antennas, Hall effect sensors, disk read and write head. Another type of transducer are electrostatic transducers like electrometer, which converts static energy from a vibrating reed into electricity, or Van de Graaff generator, which converts static into high voltage. Other type of transducers are electromechanical transducers. Examples are strain gauge, which converts the deformation of an object into electrical resistance. Then comes the galvanometer, which converts the electric current of a coil in a magnetic field into movement. Then generators, which converts mechanical energy or motion into electrical energy. Then motors, which converts electrical energy. Then comes the accelerometers, LVTD and potentiometers. Then next type of transducers are photoelectric transducers. Examples are CRT, cathode ray tube, which converts electrical signal into light energy for a visual output. Then light bulb, which converts electrical energy into visible light and heat. Then laser diode, which converts electrical energy into light energy. Then photodiode, which converts light energy into electrical energy. Then fluorescent lamps, and lastly photovoltaic cells. Then comes the thermoelectric transducers. Examples are thermocouple, which converts heat energy into electrical energy. Then temperature sensitive resistor, that is thermistor, a variable resistor affected by temperature changes. And lastly are the radioacoustic transducers. Examples are radio transmitters and receivers, and GM tube, which converts radioactive energy into electrical energy. Now let us see how can we define sensors. Okay, a sensor is a device that receives and responds to a signal. Now this signal must be produced by some type of energy such as heat, light, motion or chemical reaction. Once a sensor detects one or more of these signals as an input, it converts it into an analog or digital representation of the input signal. Now, human beings are equipped with five different type of sensors. Now, so from the diagram as well, we can see that all the human beings are equipped with basically five different types of sensors. Now, let us see what are thermal sensors. Thermal sensors include thermometer. It measures absolute temperature. Then comes the thermocouple gauge. It measures temperature by its effect on two dissimilar metals. Then comes the calorimeter. It measures the heat of a chemical reactions or physical changes and heat capacity. A thermocouple is basically a device that directly converts thermal energy into electrical energy. When two dissimilar metal wires are connected at one end, forming a junction, as we can see from the diagram as well, and that junction is heated, a voltage is generated across the junction. If the opposite end of the wire are connected to a meter, the amount of generated voltage can be measured. This effect was discovered by Thomas Seedback and thus named the Seedback effect or Seedback coefficient. The voltage created in this situation is proportional to the temperature of the junction. Then comes the mechanical sensors. These include a pressure sensor, which measures pressure, barometer, which measures atmospheric pressure, altimeter, measures the altitude of an object above a fixed level, liquid flow sensor, measures liquid flow rate, gas flow sensor, measures velocity, direction. Then comes the accelerometer, which measures acceleration. Then comes the electrical sensors. It includes ohm meter, which measures resistance, voltmeter, which measures voltage, and galvanometer, which measures current. A galvanometer is a specific type of emitter used for sensing an electric current. Other type of sensors which are commonly used are optical sensors like photodetectors, which detects light and electromagnetic energy. Then comes the photoresistor. It is a variable resistor affected by intensity changes in the ambient light. Then comes the infrared sensor, which detects infrared radiation. Then other type of sensors are acoustic sensors. Examples are seismometers, which measures seismic waves. Then acoustic wave sensors, which measures the wave velocity in the air or an environment to detect the chemical species present. Other types of sensors are motion sensors, which detect motion, speedometer, which measures speed, and biological sensors, which monitors human cells. Now let us see the comparison of a sensor and transducer. A sensor is a device that detects and responds to some type of input from the physical environment. The specific input could be light, heat, motion, moisture, pressure, or any one of a great number of other environmental phenomena. For example, a mercury thermometer. The mercury simply expands when the temperature rises to give a reading for the user. There are no electrical interferences or changes. A thermistor also simply responds to the change in resistance due to the temperature change. The transducer, on the other hand, is a device that changes the physical attributes of the non-electrical signal into electrical signal, which is easily measurable. The process of energy conversion in the transducer is transduction. The transduction is completed in two steps. Firstly, by sensing the signal and then strengthening it for further processing. The transducer has three major components. These are the input device, signal conditioning or processing device, and an output device. So thank you very much. So today we discussed the topic about the transducers, what exactly is the functioning of a transducer, and what are the various elements used in a transducer. So as we have seen, there are two elements used in a transducer. First was the sensing element and second was the transduction element. Then we saw the various classification of transducers. Also, we discussed about the various type of transducers which are used in day-to-day life. So thank you all.